Hello. In this video, I'm going to solve a AS level tricky question. So I read question first, then I will explain how to solve this question. So we have a diagram that tells the story. Okay, we have a question one. The diagram below shows the electric two-wheel vehicle driver and the driver. We have a vehicle and the driver. The vehicle accelerates horizontally from rest to 27.8 meter per second in a time of 4.6 seconds. The mass of vehicle is 360 kilogram and the rider has mass of 82 kilogram. So this is rest is the initial velocity. So as the vehicle starts from rest, so initial velocity must be equal to 0. So first of all, we write the given information that initial velocity is 0. Initial velocity is equal to 0 and final velocity is, that is 27.8 meter per second, and the total time is 4.6 second. Okay, the vehicle accelerate horizontally, the mean vehicle is accelerating horizontally, and its velocity increases from 0 to 27.8 in time 4.6 seconds. The mass of vehicle is 360 and the mass of rider is 82 kilogram. So the total mass, combined mass, we can add these two and we get the total mass. By adding these two, we can get the total mass. Calculate the average acceleration during 4.6 second time interval, giving you answer in appropriate number of significant figures. So in order to solve this question, so first of all, we write the equation for relativity equation. So average acceleration is equal to change of velocity, that is final velocity minus initial velocity divided by time taken. So final velocity is 27.8 meter per second. Initial velocity is 0 because vehicle is starting from rest, so initial velocity is 0. So we, and time is 4.6 second. So we divide and we get answer. Acceleration should be equal to 6.0 meter per second per second. So first answer is 6.0 meter per second verse. So this is the acceleration. Now for the part B, calculate the horizontal average horizontal force. So in order to find the force, we use second law. Newton's second law, F is equal to simple ma. So mass is the combined mass, um, uh, that is equal to, we know that 360 plus 82. 360 plus 82 kilogram into acceleration is 6.0 meter per second per second. So we just multiply and we get answer 2652. So this is average force, average horizontal force. So I repeat the question that in A part we have found the acceleration, as the vehicle start from 0 and its end velocity 27.8 and time will be 4.6 second. And in this part B we have found the force, or the net force or horizontal force. Third in the part B, state and explain how the horizontal force, forward force on the vehicle has to change for the constant acceleration to be maintained as 0 to 27.8. So in this question, we have to explain how the horizontal forward force on the vehicle has to change. Okay, so we need to explain the forward force changes during this journey. So first of all, I redraw the diagram and then explain. For example, here is the vehicle. Its initial velocity is 0. Vehicle is not moving at all. Its initial velocity is 0. After that, after some time, uh, uh, forward force, we increase the forward force on the wheels. Here is the wheel, forward force on the wheel is increasing with respect to time. When we increase the forward force, engine forward force, so there must be a drag force, because as the vehicle moves, its velocity increases from 0 to any value, for example 5 meter per second, 10 meter per second. So as long as speed increases, so it means there must be a opposite drag force appear on this side, because as we know that vehicle is moving under the air, because air coming down, So it means there is a drag force that is the opposite to the forward force. So this drag force, as we know that this drag force depends on speed, depends on speed. As you increase the speed from 0 to 5 to 10, this drag force increases. So resultant force must decrease, because resultant force is, as we know that resultant force is equal to forward force minus drag force. Forward force minus drag force. So it means this forward force is the average force that we have found. Okay, so it means the resultant force must decrease due to the action of the drag force, because drag force is opposite to the forward force. So it means in order to maintain the in order to maintain the speed of 27, mean acceleration should be 6.0. In order to maintain this acceleration, we have to increase the forward force. We have to apply more force, because air drag is acting opposite to that one. So we have to increase the forward force. So we can write as I'm explaining by written. Okay, for constant constant acceleration, there must be a constant net force. There must be a constant net force, acting on the system, acting on the system as air drag. Now second point is air drag acts acts opposite to driving force, and this driving force depends on speed of object or speed of vehicle. As you increase the speed, see, drag force also increases, its magnitude increases. So if drag force, that is opposite force, is increasing, mean the resultant force should decrease. So next point is as vehicle go faster, drag force also increases. Drag force also increases. If opposite force increases, it means this would result in net decrease in the decrease in the resultant force. This would result in net decrease of resultant force is the total force between the difference of forward force and the drag force. If you take the difference, so we get the net force. Okay, so then net force decreases. So if net force resultant force decrease, so our acceleration could not be 6. So it means in order to maintain the acceleration, so we have to apply the constant force, we have to increase the forward, so until its acceleration becomes 6.0. Thus this is the main important point. Thus to maintain constant acceleration, forward driving force forward driving force would have to increase, have to increase would have to increase, so that constant acceleration can be maintained. Okay, so it means this is the whole scenario. Okay, so we have to draw the diagram as well. So vehicle diagram, so diagram is simple, because as we know that vehicle is the forward force is this direction, this is the driving force. We say driving force or the forward force. on the wheel is it towards the right side, driving force, forward force, and the A drag is on the opposite. A drag force must be opposite to that one, that is acting opposite to the motion of the vehicle. Okay. Okay, now for the part D, for the part D, the vehicle now accelerate at constant speed of 55. So our speed becomes 55 meter per second, and power is useful power is 22 kilowatt. First of all, we have to convert this kilo into thousand, so 20,000 watt. So what is resistive force? So we have to find the force. So we use formula P is equal to FV. That is the equation for power. Power is equal to force multiplied by the speed. So we have to find the resistive force. So in order to find the force, we have to divide this power with the speed. So power is 20,000 watt divided by speed is, now speed is 55 meter per second. Now we just divide and we get the answer that is equal to, that is the forward force equal to 400 newton. 400 newton.